Hello everybody! In this lesson, we will see the concept of software reuse. We will introduce some of the main methods and techniques to reuse software and some of the most relevant quality characteristics required to reuse software. So let's start. Firstly, let me raise some questions. Why do we need to select existing software pieces to create a new software? And how can we trust on those software pieces? Well, actually, it's not easy to draw a general answer for both questions. There are several implications that can be understood from business and technical perspectives, and they will lead us to see the creation of new software as a collaborative activity among existing software artifacts. The main goal of this activity will be to decrease the potential errors, to focus just in new functionality, the one that we want to deliver. From a historical perspective, software reuse has been widely studied by many authors and motivated by the software crisis in 1968 during the NATO Software Conference. In those moments, software just failed, so they decided to create the proper mechanisms, methodologies, and techniques to avoid failures. One of these actions was based on the assumption that if a software had been developed and tested, why not to reuse it? This notion implied the provision of some definitions about software reuse, but we can simplify and aggregate them in just one sentence. Software reuse is commonly defined as a process to systematically specify, produce, classify, retrieve, and adapt software artifacts for the purpose of using them in a development process. According to this definition, a software artifact must necessarily be a collaboration instrument. As it has been previously introduced in previous lectures, software will be a kind of implicit knowledge that will be embedded in a new system, product, or service. Under this context, it's necessary to analyze a piece of software as a key element for collaboration. So let's introduce an example of a system in the context of smart systems. A trip planner. When we visit a new place, we usually look for the main points of interest according to our tastes. For instance, I would like to visit this cathedral, this museum, and to eat in some restaurant, the typical local food. Let's suppose that I only have one day and I want to take the most of the new place. So if we design a software system to implement this trip planner, we should consider the data sources from which we are going to gather points of interest, events, and other related information. We will also need to recommend the proper places fulfilling my tastes, and we will finally need to represent these places in a map. In this naive example, we see that we could reuse some existing data, agenda of events, points of interest, etc., and functionality, representation of points in the map, but we can also see the necessity of creating a new service for making suggestions. This situation implies that we need to make a decision. Are we going to design and implement a whole system from scratch? Can we reuse some existing and well-tested functionality from third parties? Usually, and depending on economic and technical restrictions, we will select the second option with the aim of building something new, but reusing existing software pieces. In this manner, we can take advantage of previous efforts, save costs, and what is more relevant, focus on the new functionality. However, the selection of the proper software pieces is not an easy task, as we have previously introduced. It requires several steps, and that's why a software piece that is going to be reused should be understood as any other collaboration activity, in which we have to consider the next key points. What I'm going to define now as the magic ring for software reuse. Let's go through the different parts of this magic ring that will help us to understand the software piece as a social artifact of knowledge and functionality. Awareness. A software artifact that is going to be reused will be part of the larger software entity with a new purpose. This purpose of functionality must work under certain restrictions, and the candidates to implement such functionality must ensure that they can be plugged in the whole software entity. In the ongoing example, we need to ensure that the maps provider offers an interface. In technical terms, an API, Application Programming Interface, that fulfills our needs. Motivation. A new software system will have a leitmotif, that is, a set of specific objectives. For instance, our trip planner will have to access the main points of interest, events, and calendar. And according to a user profile, it will generate a route. This is the main objective. Therefore, the selection of existing software pieces should be driven to reach the major objective of our system. No extra capabilities or functionalities should be added. Self-synchronization. If we think in the new system as a set of coordinated software entities, then we will design and select software pieces that are perfectly tested and maintained. They should provide a specific functionality in a proper and isolated manner. For instance, in our example, we expect that the maps provider can print routes, but we shouldn't expect anything else. In this way, it would be possible to reuse software, keeping the principle of doing the right thing right. Participation. The whole is other than the sum of the parts. Different software artifacts can be designed and selected to build a higher order system. To do so, we will enable the proper mechanisms to boost collaboration between software pieces. A proper API should be defined, addressing the main need of providing services for third parties. The different software services or functionality must be correctly designed in terms of coupling, degree of interdependence between software modules, and cohesivity, degree of interdependence within a software module, to which the elements of a module belong together. In this manner, the design software will become an important component in the software system and will encourage other parts to connect to our product or service. Mediation. We are going to face the impedance mismatch problem. Two different parts that are expected to collaborate cannot because of the lack of standard protocols, data formats, or any other issue. However, we can tackle this issue by using standards and enable adaptation and extensibility mechanisms. For instance, we can use design patterns, dependency injection, and other design mechanisms to improve our software artifact. Reflection. When we select or design a software artifact, we should consider this feature that is directly related to the capability of self-awareness. Our software functionality should be able to dynamically adapt its behavior to different needs and situations. It may accomplish with the quality factors of extensibility, flexibility, scalability, and elasticity. In this manner, a software artifact will be reused if new features can be easily configured without new human intervention. Engagement. A software artifact is not anymore an isolated entity. It is something that will deliver functionality and exchange information. However, to boost the awareness of a software artifact, these have to be well documented, supported by a community, public or private, and tested in different scenarios. In this way, the software artifact will become a kind of celebrity, that is well known and expected to participate in different contexts. The magic ring for software reuse is an easy tool to present the notion of collaboration between software artifacts. In this lecture, we have introduced the magic ring, that suits the task of software reuse and make easier the decision of reuse on existing software piece or build our whole software system. Indeed, this is one of the most relevant and difficult questions to answer, but keeping in mind the advantages of reuse existing software, such as cost saving, it is clear that software reuse is a key concept that we must manage to think beyond isolated parts of our target system and to envision a software system as a collaborative activity between different components.